So let us consider the x of n is equal to the. So I'm going to consider the one important the general formula a to the power of n. So here the n can take the value 0 is less than n is less than or equal to the n minus 1 it will take. So we are going to find out the DFT of the sequences. So to find the DFT, I'll consider the general formula. So we can write the DFT as, so the DFT of x of n. So this will become equal to the x of k. So we can write the formula as summation n is equal to 0 to the n minus 1 x of n into omega n to the power of kn. So to find the DFT of this sequence, let us substitute the value of x of n as a to the power of n. So a is nothing but a certain constant here. Let us substitute that one here. So what we'll do is, so we'll substitute this is equal to the summation n is equal to 0 to the n minus 1 a to the power of n into the twiddle factor value omega into the power of kn. Since n is common among these two terms, let us take n common here. So this will become equal to the summation n is equal to 0 to the n minus 1 and a into omega n to the power of k to the power of n. We can take this one as a to the power of n. Let us call this as equation number 1. So since we need to evaluate for the different cases, and already we know that the formula for the fine sum of finite terms is, so we know that it is equal to the summation n is equal to 0 to the n minus 1 a to the power of n. So this is 1 minus a to the power of n divided by 1 minus a. So we provided a value should not be equal to the 1. So if a is become equal to 1, this will become infinite 1 by 0. So 1 by 0 will become equal to the infinity. Now what we'll do, so the equation 1 is in terms of the a to the power of n. So the value of a here is, so the a value is nothing but it is a into omega n to the power of k is it. Let us substitute that one. Let us evaluate the formula. So here x of k will become equal to the 1 minus a to the power of n into omega n to the power of k to the power of n. So since here it will become as per this one. So this will become equal to the n here. So omega 1 minus a to the power of n into omega n to the power of kn. So divided by 1 minus a into omega n to the power of k. So since a is the constant here, we don't know the value for this one. So even if k is equal to 0, this will become, we have certain quantity will be there. So this will not become equal to something by 0 and it will not become equal to infinity. So there is no need to worry of this case here. So now omega into the power of n, this value is equal to the 1. So we can write the value of the x of k will be written as 1 minus a to the power of n divided by 1 minus a into omega n to the power of k, and this will take for the all the values of k, it will take there. So k can take the all the values from 0 to the n minus 1. So this is the values for the x of k for the sequence x of n is equal to a to the power of n. So this is the. So similarly, let us consider some general terms for the x of n here. So I'm going to consider the general term we'll consider, that is the twiddle factor. Let us look into the values. Let us take x of n is equal to the delta of n. So where delta of n is nothing but it's an impulse function. Let us find out the DFT of this one. And we know that the value of delta of n, so this is equal to 1 for n is equal to 0 and 0 for n is not equal to 0. So this is the value for the impulse function. Let us find out the DFT of this one. So first let us write the generalized formula, that is summation n is equal to 0 to the n minus 1 x of n into omega n to the power of kn. So let us substitute the value of x of n as the impulse function, that is summation n is equal to 0 to the n minus 1 delta of n into omega n to the power of kn. So since we know that it is defined for n is equal to 0 only, so with when if I substitute n is equal to 0, omega n to the power of 0 will become 1, and this entire summation will become equal to the 1 will get here. So therefore we can say the value of x of k is equal to 1 for the x of n is equal to the delta of n here. So here k can take the value from 0 to the n minus 1 it will take here. So this is the DFT of the impulse function which can take the value that is x of n can take the value delta of n here. So similarly we can find out the DFT of the shifted sequence. So let us find out the DFT of the shifted sequence here, that is x of n is equal to delta of n minus n naught. So this is having the value 1 when n minus n is equal to 1. So this implies that when n is equal to the n naught, and this is equal to 0 for n is not equal to the n naught. So let us find out the DFT of this. So let us substitute the value of x of k. So it is summation n is equal to 0 to the n minus 1 x of n into omega into the power of kn. So in place of x of n, let us substitute the value for the delta of n minus n naught. Let us substitute here. So this will become equal to summation n is equal to 0 to the n minus 1 delta of n minus n naught into omega into the power of k into n. So we have seen the delta of n minus n naught is equal to 1 when n is equal to n naught. So if I substitute n is equal to n naught, wherever n is there, if I substitute n is equal to n naught, so this will n is not equal to n naught, this entire summation is equal to 0. So therefore we can say that the value of x of k, so it is equal to the 1 for n is equal to n naught. So we can write this is equal to the omega into the power of k into n naught here. So here the k can take the value from 0 to the n minus 1. So this is the DFT of the sequence, which is x of n is equal to the delta of n minus n naught. So similarly, we can find out the DFT of the generalized function. Let us take the another generalized function as let me take as x of n is equal to, I'm going to take it as a function which is e to the power of j omega m n will take here omega mn. So here n can take the value from 0 to n minus 1. And for this one, the exponential function, let us find out the DFT. So I'm going to write the formula for the DFT, that is x of k is equal to summation n is equal to 0 to n minus 1. Let us write this generalized form. So x n into omega into the power of kn. Okay, let me substitute the value for the x of n. So we can rewrite as summation n is equal to 0 to n minus 1 in place of x of n e to the power of j omega mn into omega into the power of k into n. Let us substitute. Now let us take n common among these terms. So this will become equal to the summation n is equal to 0 to the n minus 1. So e to the power of j omega m into omega into the power of k. So whole to the power of n, let us take whole to the power of n, let us take here. So here omega is nothing but it's a value of omega which can take the value 2 pi by n. It will take here. We can express this one in terms of the twiddle factor also we can express here. So here the value of omega n. So we can express this exponential function e to the power of j omega m n. So here this is the term which is called as m. Mn can be expressed as e to the power of j. So it is the value for the omega is 2 pi divided by n into m into n. So in terms of the twiddle factor, it will become omega into the power of minus m. Since it's a plus is there, minus m into n will get. So if I substitute in this equation, the x of k, this x of k will become like this. So it is equal to the summation n is equal to 0 to the n minus 1. And in place of e to the power of j omega n, we can substitute as omega into the power of minus k m n. So since it's a k m n is there, it's a m n, k is not there. K is not there here. So it is m n will get as m n into omega into the power of k into n. So let us take the n common among this one. So will become summation n is equal to 0 to n minus n omega into the power of, if I take n common among this one, so it will become equal to the k minus m into n will get. K minus m into n will get here. So let us evaluate for the twiddle factor, which is having the value omega into the power of k minus m. So this value will become equal to the, similarly we can evaluate this one by applying the sum of finite terms formula. So the formula is, so we know that it's a summation n is equal to 0 to n minus 1 a to the power of n So this is equal to the 1 minus a to the power of capital N divided by 1 minus a. So provided a should not be equal to the 1. So I'm going to call this as equation number 1 here, and let us evaluate this one. So as per this formula, it will become x of k will become equal to the 1 minus omega into the power of k minus m whole to the power of n divided by 1 minus omega into the power of k minus m. So you have provided omega into the power of k minus m should not be equal to 1. So this implies that omega into the power of k minus m. So this will become equal to 1 when k minus m is equal to the 0. So what we can do is, so this case we can take as, so k minus m should not be equal to 0, or else we can state this one as k should not be equal to the m here. So and here we know that omega into the power of n, whatever it may be the coefficient, so this will become equal to the 1 here. This will become equal to 1, so that the value of x of k, the value of x of k will become equal to the 0 will get here, because 1 minus 1 will become equal to 0. So x of k will become equal to 0. So for the case when k is not equal to the m, so this is the value we got for k is not equal to m. So now in the equation 1, in this equation, what we can do is, let us substitute k is equal to m in this equation, and let us find out the value here. So let us do that one. So what we can do is, let us substitute k is equal to m. So let us substitute k is equal to m in equation 1. So in the equation 1, if I substitute here, so what will become is, the x of k will become equal to the summation n is equal to 0 to the n minus 1. When I substitute k is equal to n, it will become omega into the power of 0. So this will become equal to the summation n is equal to 0 to n minus 1, 1. So this we can write as the n we can write, because when you're going to take the add the 1 n number of times, this will become equal to n. So this is for the value k is equal to the m here. So let us summarize. What we can write is this expression. So what this expression is there? So this will become equal to the 1 when k minus m is equal to the, when k is equal to the m, and this will become equal to n when the k is not equal to the m here, it will become equal to 0. So we can write this one as, we can write the DFT, that is the sequence x of k, we can write as, we can summarize it. So x of k is equal to 0 for k is not equal to the m, and this will become when k is equal to the m.